Today we're going to study the Pythagorean theorem. We'll try to discover what it means and how we can use it in real life. So let's start with this basic right triangle. A 3, 4, 5 triangle. This is a right triangle because of this side, which is 90 degrees. Alright, so let's start with some vocabulary. Let's start with the legs. The legs here would be 3, which has a name called altitude. Let's just call it A. And 4 is also a leg, and let's call it the base. We use the letters A and B to designate which is altitude and which is base. Alright? So, how will I know that they're the legs? They're the ones connecting together to form the 90-degree angle. So, another vocabulary is hypotenuse. Can you say that? It's hard to say it. Say it? Hypotenuse. Awesome. So, hypotenuse is the longest side. It is the one opposite the 90 degrees. See? So, that's the longest side. Hypotenuse opposite the 90 degrees. So, that's 5. Okay? And obviously, 5 is longer than 3 and 4. Duh. So, it's the hypotenuse. We will make a bigger square from the given altitude. Let's start with these 3. I'll make a bigger square from here. Check this out. I put 1 square. Let me put some more squares over here. 1 more for you. 1 more. 1 more. I also want to make a bigger square over here. So, let me put some more. 1 for you. 1 more. 4 by 4. So let's throw 1 square over there. More. Okay, more. What's the point of this? Look at those little squares. Can you count them? How many little squares can you see on this side?
9.
Do you have to count 1 by 1? What's the shortcut?
3 times 3.
And it's a 9. Correct. How about here? How many little squares are there?
16.
16, because you did 4 by 4. 16. And over here, how many?
25.
25. Now, my point for you right now is to see a relationship. What can you say about 9, 16, 25? Check this out. I get that 9. I get the 16. I added. What do I get?
25.
The 25. Are you sure, Ram? Let's check. Okay, let's check it out. Let's show it in another way. Those 9 by 9, let me distribute that. I put you those 3 here. Let's move some more. Move some more. Move some more. You go over there. What's this? 5 by 5. How many?
25.
25. See that? So, to understand it more fully, look at this. The square formed by the legs, this is the square of the legs, is filling up the bigger square. See that? It's made up of water and it's filling up the space to make the bigger square. Now, a while ago, from the altitude, we said 3. What did we do with 3? We did the number of squares formed by the altitude. That 3 was able to form how many? 9. Now, how about this? That 4 was able to form the number of squares formed by the base of 4 is now 16. The number of squares formed here is based on the numbers of squares formed by the hypotenuse. That's a 5 by 5. We got 25. How do I write this? The number of squares formed by the altitude. See that? That 3 was squared. So you got a 9. You see connection? Here. This 4 was squared. That's why you got 4 squared. This 5, that 5 was squared. So you got 5 squared. Now, let's see the relationship. Whatever your altitude is, square it. Whatever your base is, square it. And whatever your hypotenuse is, square it. What will happen with these 2 squares? Do we multiply them? No. We add them. And whatever total squares you have here will be equal to the hypotenuse square. So this is so important. It started by this guy. This guy is a Greek nerd. His name is Pythagoras. Now, Pythagoras studied all the right triangles. Remember, we started with 3, 4, 5? He studied other combinations of triangles, and he also found the same thing. he always discovered, he said, OMG, this A squared plus B squared equals C squared works with all right triangles. Let me call this now. He's so proud. He said, let me call this now the Pythagorean theorem. And because of this Pythagorean theorem, you can solve for the height of walls even though you don't have a ruler here. Knowing these two, you can solve for the distance if you want to make a shortcut in a golf course. You can solve for the distances between structures because of Pythagorean theorem. We will now apply how to use his theorem.